Good evening, children.
Good evening, ma'am.
Great, you all have joined. Okay, let's begin today's class. See, in previous class, we were studying about Euclid's. Okay, we have done Euclid's axioms. We have done Euclid's postulates now. So, was everyone thorough with the Euclid's fifth postulate? Yes, everyone could understand that.
Yes, ma'am.
Please keep your videos on. Everyone must keep their videos on. Rohit, Akshara, Sampath, Jitendra, Yukta, Purujit. Jitendra, keep your video on. Sampath, Yukta, Rohit. So we had done the postulates. Okay. We had done the postulates of Euclid. So everyone could understand the fifth postulate.
Yes, ma'am.
Great. So fifth postulate is an important one because it is exactly asked as it is. State Euclid's fifth postulate. Okay, there is no twist and turns in the question. It's directly asked for whatever number, whatever marks. Okay. So let's do today. Today we'll do some questions based on it, right? So you'll get to see how is the question asked on this chapter, right? And yesterday also on the WhatsApp, I had shared some basic questions. Did you go through that? Some basics of this chapter I had shared on the group. Yes?
Yes,
Okay. So I'm sharing the screen. Okay, but before moving to the question part, let's see if anything is left in this chapter which needs to be explained. Let me just see. Okay, so in this chapter, you don't have nothing much now. Its only thing is the equivalent version of Euclid's fifth postulate. There came another mathematician whose name was John Playfair. Okay, there was another mathematician whose name was John Playfair. He gave different versions of postulates, fifth postulate, Euclid's fifth postulate. His name was John Playfair. Yeah, what is happening? Okay, so that's 1 second, 1 second. Let me check what is happening here. Oh. Just a second. This is not your page. Your class is 9. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Right, so this is what we were doing. So there came another mathematician, that was John Playfair, right? He gave different versions of fifth postulate. So sometimes, these versions are also asked. So you don't have to do anything in this, just read the statement, okay? And nothing else to be done, right? It says, for every line L and for every point P not lying on L, there exists a unique line M passing through. So don't go into this. You will confuse otherwise. Okay, let's do some sums now. Question time. Today's date is 3rd. Okay. So how many lines can pass through a given point? Who can tell me?
Infinite.
Infinite. Okay. This is also a question which I'm asking you. Okay. I had shared these questions on the group also. So infinite lines can pass through a given point. Okay. How many line segments can be determined by 3 collinear points? If I have 3 collinear means those points which lie on the same line. So how many line segments can pass through this?
3, ma'am.
How many line segments can be determined? Yes, 3. 1 from A to C, from C to B, and from A to B. Right? Okay. How many line segments can be determined by 3 given non-collinear points? Now, if I have some non-collinear points, non-collinear means which are not lying on the same line. So, how many line segments can be formed?
3.
From A to B is 1, B to C is another, from A to C is another. So, these are again 3 lines. Okay. Explain when the system of axioms is called consistent. Okay, when do we call the system of axioms as consistent? See, consistent is one word. If system is consistent when we say that if one axiom does not contradict the other axiom, please write here, if one axiom does not you understand, does not contradict.
Ma'am, contradict me.
That means when we are talking of one axiom, another axiom comes in between and it does not allow the axiom to work. So that is, something that is contradictory. Does not contradict the other axiom of the system.
Okay.
So if it does not do that, then that means the system axioms are consistent. Okay, let's do this another question. Now this is the figure I'm showing you here, like this. If I say angle 1 is equal to angle 2 and angle 2 is equal to angle 3, okay? Angle 1 is equal to angle 2 and angle 2 is equal to angle 3. Then show that angle 1 is equal to angle 3. Can you show that? If 1 is equal to 2, 2 is equal to 3, then it's obvious that 1 will be equal to 2 will be equal to 3 also. Is it? 1 will be equal to 3 also. 1 is equal to angle 2. 2 is equal to angle 3. So can we say that angle 1 is equal to angle 3?
Yes, ma'am, because of using the
So which axiom follows here? Which
first
axiom follows here?
Ma'am, things which are equal to the same things are equal to one another.
Yes. So things equal to same things are equal. Okay. Things that are equal to same things are equal. Yes. So this is how you have to, these questions are asked. So which axiom follows here? Okay, let's see some more examples in this. Okay, let's take this. In a triangle, okay, I'm taking this. In a triangle PQR, this is some triangle. You want to write the question? Then please write. I'll write the question first. Please write down the question. In a triangle PQR, in a triangle PQR, you will be making the shape also here. Okay, this is triangle PQR. In a triangle PQR, QO and RO are the bisectors of angle PQR and angle PRQ. You understand what are bisectors? Bisector of an angle. Bisector is something, if it is saying OQ is a bisector of angle PQR, that means it is dividing this angle into two equal parts. Bisecting means dividing into two equal parts. Bi means two. Okay. Such that angle PQR is equal to angle PRQ. It is bisecting these two angles in such a way that PQR is equal to PRQ and angle PQO is equal to PRO. Show that angle RQO is equal to angle QRO. That means you have to show that angle RQO. That means this angle, I'll show you with another pen. Okay, that means this angle is equal to QRO. QRO is this. Okay. Now it was given to you that angle, this PQR and PRQ are equal. Okay, this was given here that these two angles are given. We are also given that PQO and PRO, these are also equal. So we just have to show that the remaining part of the